This is episode 3 in a series chronicling my adventures in building a DIY CNC router. If you missed episodes 1 and 2, I encourage you to go back and check them out. That way this video will make a whole lot more sense. Well, let's get to it and let's give it a try. Continuing where we left off in episode 2, it's time to start prepping the Y-frame tubes to accept the ball screw mounting blocks as well as the linear rails. Checking the wiki and verifying with the Fusion file shows me not only the drill guides I need to print, but also the first actual printed parts that are needed, 2 sets of BF and BKHM risers. My plan is to paint all the steel parts a nice red color, so I decided to make all the printed parts black. I'm using standard plain old PLA for this. With everything printed, I begin with the now all too familiar transfer punch, reinforcement punch, drilling and tapping of the BF mounting risers, which will be at the rear of the machine. These are 5mm holes. The holes are tapped for M6 fasteners and the BF riser is set into place. There's a bit of play in the holes on these parts, so I used a square to get the front face of the riser as perpendicular to the center line of the tube as I could. With both BF risers mounted, it's time to tackle the linear rails. Back in episode 1, I mentioned that most of the hardware for this build was purchased through a service by 3Design, the original creator of the PrintNC project. On his site was a calculator that you could use to plug in your size requirements and a list of the parts would be generated, all sized to match. The service would then source all the parts from various AliExpress type shops, and in 6 to 8 weeks, a bunch of heavy and heavily taped up boxes would show up. This means all the linear rails are already cut to length, which is where the problem crept in. I'll get into that later in the video. The rails have a cosmoline coating, which is typical for this kind of product. I wipe off the excess, but not all of it. I wanted to keep a light coating to prevent corrosion while I'm building this thing. The rails seem to be fairly straight, but they were dinged up a bit. These are not the highest quality linear rails, so we'll see how they perform. Satisfied enough to move on, I wiped off the mating surfaces from the first Y-frame tube. I probably should have removed the mill scale at this point, but my fear was that the tubes would start to rust as it was summer at this point and quite humid in the shop. I appeased myself by thinking the mill scale won't affect the placement of the mounting holes, so as long as there's no burrs or chunks on the surface, I should be okay to proceed. These clever alignment brackets really are a game changer for getting everything aligned properly, but it was clear that I would need a couple more, so I have them baking on the printer. To verify things are lining up properly, I put some layout fluid on the tube and used the drill guide's center notch to scribe a center line down the length of the tube. I put the rail back on and checked to see if that center line was visible at the approximate center of the holes in the rail. Convinced I was on the right track, I marked up the center line on the second Y-frame tube. The heat gun is key to drying down the layout fluid quickly. With 2 more alignment guides printed, it was time to mark out the holes for this rail. I used a drill guide with a clamp to hold the rail tightly in place. I need to mark and create 13 holes, and precision here is critical. If the rail shifts halfway through or gets knocked out of alignment each time the punch is struck, The holes will not line up exactly and the fasteners will not fit. A snug fitting transfer punch is critical here, and a 5/64 inch or just under 6 millimeters was the best fit I had. All of the prior transfer punching I had done was directly on the wooden bench top. I had a dream the night before that told me if I set up something more substantial and less prone to absorbing the blows, my punch marks would be a bit more pronounced while needing to use less force with the hammer. To that end, I used a few pieces of 3/8 inch plate I had in the corner as a base to punch on. Did this really make a difference? I think so, but it may have just been a fever dream. What do you think? I should also say, when transfer punching, strike the punch once and only once. Multiple strikes will invariably lead to multiple marks, and that ain't precision. Something else that became apparent is that these rails will be a custom fit to each of these tubes. I mentioned that they were cut to length before I received them. Again, more on this biting me later on. But they are not actually the same length, so the holes will be slightly offset from each other. So mark everything. I'm marking this as the right side rail. The tube is already marked as right on the piece of blue painter's tape. Even though the punch marks looked quite good, I still felt the need to go back and reinforce, being extremely careful to get the punch in the already created mark. With the first rail marked, it was rinse and repeat on the second Y-frame tube. With this second run, I was pleased with the quality of the original transfer punch and decided no secondary punch was necessary. Over to the drill press, and using a center drill bit, I lined up each punch mark, clamped the tube, and drilled the pilot hole. I was very concerned about the precision on these holes. You can only drill a hole once, and even if one was out of alignment, the fastener would not fit and that section of the rail would be compromised. So I took my time, lined things up, and chose precision over speed. As mentioned last episode, I used the Green Anchor Lube metalworking compound. This is a water-based lubricant for drilling, tapping, and sawing, and I love it. I'm still not sponsored by them, but it's still good stuff. As always, links to the tools and products used in this video will be in the description below. With all the center drilling done, the 4mm holes are drilled, 26 in all. At this point, I decided the center drilling provided enough precision to not have to reclamp the piece every time. This cut down the time by quite a margin, but was still within acceptable precision parameters. With all 26 holes drilled out to 4 mm, it was time to tap each one for M5. The electric tapping arm to the rescue once again. For more information on this invaluable tool, check out the tool tryout video I made a few months prior to this. With all the holes drilled and tapped, it's the moment of truth time. I was pretty apprehensive at this point. If I couldn't get the screws in because of an alignment problem, I'd have to start over with new tubes, and if you've been following this entire series so far, you'd know that that would be a huge pain. First rail on with no problems. So far, so good. Second rail on, again, no problems. Nice. It's all downhill from here, right? Well, you know that issue I kept mentioning about getting all the hardware pre-cut from the website? It's now biting me. It took me a while to figure out exactly what happened because I took all of my measurements directly from the Fusion model, which was sized to my exact requirements. At the time I started collecting all the parts for this build, I did not really understand the difference between the wood cutting and the metal cutting versions of this product. When I ordered the hardware package, it must have gotten marked as a metal cutter somewhere, and I was either not aware of what that meant or something got crossed in the communication. Because the metal cutting version features dual bearing blocks on each of the linear rail carriages, the length of the ball screw and linear rails have to be longer to compensate. Therefore, the Y-frame tube length would need to be 925 millimeters in length instead of the 875 millimeters I currently have. What to do? Well, I could easily cut the linear rail shorter, but I can't cut the ball screw. I could remake the Y-frame rails, but I'd have to order more steel, then basically start over from scratch, rebuilding the entire frame? No, thank you. After losing a night's sleep about it, I decided that because the extra length needed was not really critical to the linear motion of the machine, and only needed to attach the back half of the BKHM risers in the motor mount, I could use the pieces I originally cut off the tubes and weld them back on. My largest concern was, because welding injects a lot of heat into the metal, the forces of that heating and cooling could twist the tube and ruin the mounting for the linear rail. And also, I'm not a trained welder. I know some of the principles, but as you will see, I am not at all practiced nor proficient. With all those caveats voiced, I removed all the hardware from the tubes and prepped them for some welding. The first thing I did was to grind a bevel on all the ends to be welded. This was hopefully to help compensate for my lack of skill, allowing me to get a decent root weld without injecting a ton of heat into the metal, thus minimizing twist. I used my welding table. No, I don't weld that much, but yes, I have a small fabrication table. I tried to get the two pieces clamped down and as immobile as possible. I know there's no way to stop the steel from moving due to the stress induced by the heat, but my hope is through a combination of good clamping and short duration welds, I come out of this thing with something that doesn't resemble a pretzel. Were I a better man, I'd use TIG, but now is not the time to experiment even more, so MIG it is. I started out with 2 quick tacks on either end and checked the heat on either side. Not too bad, so I waited about 20 minutes for things to cool down completely, flipped the part, reclamped, and tacked the other side. To allow that piece time to cool, I loaded in the second frame tube and did the same tacking procedure. I then went back to the first piece and tacked the top and bottom, switching it out, and did the same for the second piece. By now everything was tacked up and cooled down. My well of inexperience was telling me that the greatest danger from malforming the steel was over, but I should still take it a piece at a time. I made a series of short welds, turning the piece over and working the opposite sides to try to offset as much stress as possible. When I felt the piece I was working on was getting too hot, I switched out to the other. By the time I was done, I had some very ugly, not completely filled welds, but I felt there was enough integrity there to support the small load that was required of it. While grinding this down with a flap disc, I remember thinking to myself, I should never show this to anyone. To all of you welders out there, my hat's off to you. With the extension in place, I reinstalled the BF riser block, the linear rail, and set the ball screw in place to get a general idea of where the BKHM riser should go. Using the template, the hole making process was again executed, drilling 5mm holes and tapping for M6. The hardware was reinstalled for a final fit and to make sure everything comes together properly. Crisis averted, and another good day's, or a couple days' work. Well, the machine's coming along. Hopefully I won't run into any more issues. Yeah, right. Please leave a comment with your thoughts on the build so far. Strike a like and subscribe to the channel so you don't miss the next episode, where we'll move on to building the carriage blocks and the gantry. Until next time, I'm mainejason. Get out there and give it a try.